calculate voltage drop, we'll go through several steps. Firstly, we need to determine the load current. For a 40 horsepower motor, we convert horsepower to watts using the conversion factor of 1 horsepower equals 746 watts. Therefore, 40 horsepower multiplied by 746 watts per horsepower equals 29,840 watts. For the 14,077 volt amps per phase, we use the formula volt amps equals volts multiplied by amps, so amps equals volt amps divided by volts. This gives us 14,077 volt amps divided by 400 volts, which equals 35.19 amps per phase. Secondly, we need to calculate the resistance per phase. For 2 American wire gauge wire, which is approximately 35 square millimeters, the resistance per 1000 feet is 0.53 ohms per 1000 feet. Given a circuit run of 400 feet, the resistance per phase is calculated as 0.53 ohms per 1000 feet multiplied by 400 feet. Finally, you divide it by 3 to account for the 3 phases in the question. This gives us 0.7 ohms per phase. Thirdly, we calculate the voltage drop. The voltage drop is calculated by multiplying the resistance by the current. For the 40 horsepower motor, the voltage drop per phase is 0.7 ohms per phase multiplied by 35.19 amps, which equals 0.246 volts. For the 14,077 volt amps load, the voltage drop per phase is 0.7 ohms per phase multiplied by 35.19 amps times 3. We multiply by 3 because the value is given per phase and not as a combined total. This equals 0.738 volts. In conclusion, since the circuit is rated for 40 horsepower and the voltage drop calculations show that the maximum voltage drop for a 40 horsepower motor is within acceptable limits, usually 3 to 5%, you should use the 40 horsepower load for your voltage drop calculations. For a 400 volts 3-phase circuit with a 40 horsepower motor load, the voltage drop using 2 American wire gauge wire over a run of 400 feet is approximately 0.246 volts per phase. The voltage drop for the 14,077 volt amps load is approximately 0.738 volts per phase, which is not representative of the actual load.